Hello everyone, welcome to the tutorial on how to fine-tune a LLAMA 3.1 model on your own dataset using Unsloth. Today we will discuss about supervised fine-tuning techniques, then we will see what is Unsloth, then we will fine-tune LLAMA 3.1 model with Unsloth, and then finally loading the fine-tuned model to the HuggingFace hub. So let's get started. What is supervised fine-tuning? Supervised fine-tuning is a method to improve and customize pre-trained LLMs. It involves retraining base model on a smaller dataset of instructions and answers. The main goal is to transform a basic model that predicts text into an assistant that can follow instructions and answer questions. SFT can also enhance the model's overall performance and add new knowledge or adapt it to a specific task and domain. There are three popular SFT techniques: fine tuning, full fine tuning, LoRa, and QLoRa. So, full fine tuning is the most straightforward SFT technique. It involves retraining all the parameters of pre-trained model on an instruction dataset. This method often provides the best result but requires significant computational resources. That is, several high-end GPUs are required to find an 8 billion model. Low rank adaptation, that is LoRa, is a popular parameter efficient fine tuning technique. Instead of retraining the entire model, it freezes the weights and introduces small adapters, that is low rank matrices, at each targeted layer. This allows LoRa to train a number of parameters that is drastically lower than the full fine tuning, that is less than 1%, reducing both memory usage and training time. Now coming to QLoRa, that is quantization low rank adaptation, is an extension of LoRa that offers even greater memory savings. It introduces up to 33% reduction in the memory compared to the standard LoRa, making it particularly useful when GPU memory is constrained. We will utilize these techniques for fine-tuning the LLAMA 3 model. Now let's discuss about the Unsloth. LLAMA 3 is an amazing open weight model, and you can fine-tune this model with your own data. For fine-tuning our own dataset, there are a number of options. Today in this video, we will discuss about Unsloth. It is one of the easiest way to fine-tune a model on our own dataset as it actually faster. We are going to be use its official notebook and it describes everything in very user-friendly way. So let's get started. We will be using this LLAMA 3.1 notebook. We can open this notebook in a Google Colab as well as on the local machine. Today, I will be using Google Colab as it providing free T4 GPU. So let's connect the T4 GPU. Firstly, after connecting the T4 GPU, you can see the available system RAM, GPU RAM, and disk space. Now let's install all the required package and dependencies. Now, here we need to set up some training parameters such as maximum sequence length, data type, and 4-bit quantization. Now, Unsloth uses its own existing LoRa adapters to do efficient fine-tuning. Here we are using Unsloth LLAMA 3.18b model, but if you want to use any other model from the HuggingFace, you can mention it by providing your token, access token here. You can also save this access token in the secrets by giving the value of the access token and utilizing this access token by importing this statement. Now we add LoRa adapters as we only need to update 1 to 10% of all parameters. So you have to run this one. Now coming to the crucial part, that is data prep. It is one of the major things you have to do to define your own dataset in such a format that is accepted by the model. For fine tuning, for example, I'm giving my dataset here, which I have already uploaded in the HuggingFace. Let me show you. Go to your dataset section and you can save the new dataset here and keeping it public. So I have already loaded one dataset, as you can see here. So this is the instruction I'm giving, and here is the output I'm expecting. So it consists of the number of instructions as per my resume, and here is the answer I have provided. So I'm using this dataset. So our prompt will be a text string, which takes the instruction and of the dataset and put it here, and then the response of the model and format it into a text string here. And we add this text as one more column in our dataset. Make sure to include this end of sequence token because it is required to stop our generation from the model. Otherwise, it will generate the tokens for forever. So we have to use this end of sequence token. Now, once running this step, you can see the data set. Here, the instruction, output, and one more newly added column text is added. I'm printing one row from my data set. So this is the instruction and this is the response. And it is coming in the format we have defined here. And we are printing the text column. So this is the text column, which consists the instruction and response. Now coming to the training part of the model. So as we discussed the supervised fine-tuning technique, we are utilizing this SFT trainer, that is supervised fine-tuning trainer from HuggingFace. This is based on the HuggingFace transformer library. So it will accept the model object, that is Unsloth specific model object, and we are defining the corresponding tokenizer and dataset. And then we need to specify which column we need to use. So here we are using the text column that we have newly added, and then the max sequence length and some other parameters for controlling the model to how it will be performing. So here we are defining the max number of steps. So I'm giving the 60 as a maximum number of steps because my data set is smaller. You can increase the size as per your data set. So once running this step, we can see the current memory states. That is the GPU, T4 GPU is used and it has a maximum memory of 14.748 GB, and our task has utilized this much of memory. Our training object is set, and now we can call the training function on the trainer object. Now, as we can see, the model is decreasing consistently. It means that the model is learning and it runs for 60 steps as we have mentioned over above. So here are the total number of 60 steps model has trained. Now coming to the final memory and time stats. So you can see that for training, 4.62 minutes required for training. It took like 4.62 minutes and the total memory was 11.812, and you can see all the stats over here. Now coming to the inference part. As we have already trained the model, let's see the inference. You can write any instruction and leave the output blank. So I am written an instruction, what certification stand by me. So, and I have left the output as blank. So once you run this, also define the maximum new number of tokens you want to generate. So my data set is smaller, so I have only provided 64 as a value, but you can increase as per your data set. So once running this part, I got the result. I have a certification, what number of certifications I have, it has provided accurately as per the training data set. Also, there is one more way to specify the response using the text streamer. It used to generate the streaming response. So here also I have provided like continue talking about me. So here I have also leave the output as blank and it has generated the output as you can see here. Now coming to the saving the model, which we have just fine-tuned. So on saving it to the HuggingFace hub, we have to specify the token. So I'm utilizing this import statement and storing an my token as an HF equals to underscore token, and I'm providing this token over here. So it will push the model into my HuggingFace directory. So you can see this URL has been created. Let's go to this URL. So it has successfully uploaded the fine-tuned model. It has also described that what kind of model was I have used. So I have used the Unsloth LLAMA 3.1 8B BNB 4-bit model. So also you can save this model locally on your local machine. So you using this statement and running it, it will save it in your local directory. So that's all for today. Thank you for watching.